Hello and welcome. Today we're doing a question from LeetCode called combination sum 2. It's a medium. We're going to jump right into it. Given a collection of candidate numbers candidates and a target number target, find all unique combinations in candidates where the candidate numbers sum to target. Each number in candidates may only be used once in the combination. Note the solution set must not contain duplicate combinations. Example 1, we have the following candidates and we want all combinations that sum up to target 8. So here we have 1, 1, 6, and we're not using duplicate ones here. We actually have two ones in our input. Then we have 1, 2, 5, 1, 7, and 2, 6. Example 2, we have 2, 5, 2, 1, 2, and target is 5. So here, every combination that sums to 5 is 1, 2, 2, and 5 by itself. Okay, this is combination sum 2, and we've done combination sum 1 before. I'm going to link it down below so you don't even need to go looking for it, but I highly recommend checking that out before doing this because it's just going to build up. The only difference between this problem and combination sum 1 is that here we have duplicates allowed in our input, and we can't use numbers twice. Otherwise, it's the same concept, right? We want to find all combinations that sum up to target. So how do we make combinations? Well, to recap that, if you haven't seen that first video, say I have 1, 2, 3 as my input, and my target is 4. Well, to make a combination, I'm going to pick a number from my candidate. Say I go with 1. This is one combination that I've made so far, and I see that it doesn't sum up to target, right? I have target 4, so this is not a combination I can end up outputting. So now I want to go ahead and continue making combinations. Now, what other numbers can I add to 1 to continue making combinations? I've already used this first one, so I can't use it again. Each candidate must only be used once in a combination. So now I only have 2 or 3 available for me to use. Say I go with 2. One combination is 1, 2. I see that this is 3, target is 4. I can't add this to a resulting output as my solution. So I want to continue making combinations. At this point, the only number left would be 3. So a combination we could make is 1, 2, 3. Again, here, it doesn't equal target, so we can't use this combination, and instead we want to continue making them. Now, to continue making them, there are no more numbers for us to use, so we want to see if we can replace this 3 with anything. Well, there are no more numbers for us to replace 3 with anything either, right? We only had 1, 2 available. There's nothing else besides 3 to put here, so we're going to go back another index. At this point, I had either 2 or 3 to use. I've exhausted all my 2 possibilities, so with 1, now that I'm done with 2, I can pair it up with 3. Now I see that this does sum to target, so I'm going to add this to a resulting array. I have 1 and 3 as a combination here. So now that 1, 3 are complete, what other numbers can I append to make this a bigger combination? I can't append anything because I'm already at 1 and 3. I can't go back. Over here, I have my first character being 1. For my second number over here, I'm at index 2. I can only add numbers that are greater than my current index. I can't go back. If I did that, if I added a 2 over here, I would have the same combination as the one before me. I would be duplicating that. So in order to avoid duplicates, we can't go back. Now that 3 is done, we've fully exhausted all possibilities with 1. So now we're only going to look 2 and onwards. So with 2 and onwards, one combination I can make is just 2 itself. Something else I could do is 2 with 3. And there's nothing else to add or change here, so all combinations including 2 are also done. The only thing left is 3. And we would just have 3 by itself. Again, we can't go back, right? If we were to go back, we'd be duplicating combinations, which we don't want to do. So these are all combinations I can make with the following candidates, and only one of them resulted in our target. Now this is fairly simple. This is what we did before in previous combination problems. I'm going to link them all down below. But here the problem is that our candidates can appear twice. We have 2 1s over here in example 1. So how do we avoid duplicates in this situation? So say my candidates was actually 1, 2, 3, 1. There's an extra 1 at the end over here. Now if I were to follow the same logic, what would we do, right? We have a combination of 1, then we do 1, 2, 1, 2, 3, 1, 2, 3, 1. Up until this point, it's fine, right? We can use 2 1s because we have 2 1s available to us. We haven't made any repeat combinations either. Now, what are the next set of combinations I can make? I went down this entire path of 1, 2, 3, 1. I can't make anything else here. I can't add on or change 1 with anything. So I'm going to go back in index and see if we can change anything here. At this point, I had either 3 or 1 available to me because the last index I used was 2. Anything after that, anything after the indices that I've just used is available to us. So over here, I can do 1, 2, and instead of 3, do a 1. I can't add anything else because this was the last index. I need something more, but there's nothing else after that. And I can't change this with anything else either. So I go back, now I do 1, 3. Both of these actually also sum to 4, so I'm going to add this to a resulting array. So I have 1, 2, 1, and 1, 3. Now if I want to continue making combinations, what can I do? I just did 1, 3. I can do 1, 3, and 1 as well. So I do 1, 3, 1. After this, what can I do? Well, as of right now, I've exhausted 1 and 2, 1 and 3. I'm going to do 1 and 1. So over here, I can do 1 and 1, but there's nothing else to add on after 1 and 1. So I go back and instead of using 1 at all, now I'm going to use 2. So at this point, I use just 2, and then I can do 2 and 3, and now I can do 2, 3, and 1. But here's where the problem arises, right? I have 1, 2, 3 here, and 2, 3, 1. These are the same exact combinations. And remember, with combinations, order doesn't matter. So these are the same combinations. How do I avoid duplicates? Well, what if there was an easy fix for this? To avoid duplicates, what we want to do is just sort. So instead of having 1, 2, 3, 1, what we're going to do is do 1, 1, 2, 3. This is because after we exhaust all combinations with that first one, so we do 1, then 1, 1, then 1, 1, 2, 1, 1, 2, 3, 1, 1, 3, 1, 2, 1, 2, 3, and 1, 3. We know we've used everything we could with this one, so we can just skip over this one entirely. We don't need to do 1, then 1, 2, 3 again. We've already covered that with that first one, and we can skip it up until we see a new number. So we're gonna go ahead and code this up and then run through this with an example to make sure we fully understand exactly why and how this works. To code this up, what is the first thing we wanna do? First thing we wanna do is sort our candidates. So candidates dot sort. And now I want an initialized resulting array. So result is going to equal the empty array. Now I want to define a recursive function. What I'm going to do is define it within this function right over here. That way I don't need to keep passing in result and candidates. I can just refer to them. It just makes for cleaner, more concise code. So I'm going to make a recursive function here. I'm going to call this combinations. And what am I passing in? Well, I know I'm going to be dealing with combination, so I'm going to save my current combination over here. And I'm also going to be looping through a very specific range of indices for every single position in my combination. In this first position, I can range through every single candidate that I have, right? I can start from index 0. But for the second position, I can only start at an index greater than the one I had before. This is to avoid the duplicate. So I'm also going to pass in a starting point for my loop. And finally, I'm going to pass in a target because every single time we append a number to our combination, I'm going to subtract that from target. So each time we're going to be looking for a smaller target. Once this hits 0, we know we found a combination that sums to target. Now with recursive functions, there are two things we want to keep in mind. One is the base case. The second is the recursive case. What is our base case? When do we stop recursing? We can stop recursing once we find a combination to append to result. So if target equals 0, we're going to append our current combination to result. So result.append current. And I'm just going to return after this. Now, if I haven't returned yet, I want to add a number to my current combination. So I'm going to loop through for I in range, and I'm going to be ranging from start. It's a very specific index that I can start with. So I'm going to range through from start to length of candidates. And over here, now I want to check to make sure I'm not at the same number that I was before me. So if I is greater than start, and candidates of I equals candidates of I minus 1, I'm going to continue. This means I'm going to skip over the number that I had at index I. If that is not the case, then I want to go ahead and add the number at index I. But I only want to add it to current if it is less than target. If it is greater than target, it will never sum up to target. We've already shot past it, right? So if I'm at 1, 1, 2 in my current array, say my target is 6, what is my current sum right now? It's 1, 1, 2, so that's 4. What is 6 minus 4? That's 2. That means I only want to look for 2, but this current number that I'm adding is a 3. So there's no point in doing that. So we don't need to check this number or if we had any numbers past this. So if candidate of I is greater than target, we are going to break out of this loop. There's no point in checking what other characters we can add to this combination. Now, if we don't go into any of these if conditions, then we want to add the candidate we have at index I to our current combination. So we're going to call combination again with current plus candidate at I, and we want to pass in I plus 1 as our next starting position. And we're also going to subtract from target candidate of I. And then all we have to do is return. So we just defined combination, and we're going to go ahead and call this. So I'm going to be passing in the empty array, passing in 0 as my starting index and target as my target. At the end, all we have to do is return result. So let's go ahead and submit this. Runtime error, candidate is not defined. That's because this is candidates, and I'm going to make that fix over here as well, all these places. Now let's go ahead and submit this. And it is accepted. Now before leaving, we're going to do a full walkthrough with an example, going through our code line by line. For our example, say we have the following candidates and target equals 4. Going through this line by line, the first thing we do is sort our candidates. So we're no longer working with these candidates, we're now working with this sorted array over here. Now we want to initialize results, so result is going to be the empty list. We define our combination function, and then we call it over here. So we're going to be passing in the empty array, the number 0, and target, which is 4. This corresponds to our current combination, start, and target. The first check we make is if target equals 0. That's not true, so we don't go in this if condition, and we're in this for loop right here. So for I in range from start to length of candidates, start is 0, so we are going to start with I being 0. So now I is 0, we go in our first if condition. If I is greater than start. Start is 0, I is 0. This is not true, so we don't go in this. Now we check if candidates of I, so what is candidates of I? That's 1. Is 1 greater than target? Is 1 greater than 4? That is not true, so we don't break either. And we just make another call. So what is going to be passed in this call? Current, which is our current empty array, plus candidates of I. So candidates at I, this is candidates, I'm going to get rid of this so we don't keep track of it anymore. Candidates at I, so candidates at index 0, is number 1 over here. So we're passing in the empty array plus an array of 1. So concatenating that together, we get just the array of 1. I plus 1, so 0 plus 1 is going to be 1. And target minus candidates of I. So 4 minus 1 is going to be 3. So we go back in this function, our new current is the array of 1, start is 1, and target is 3. We check target isn't 0. And for I in range, start to length of index. So now we start at 1 onward, so I is going to start with 1. Is I greater than start? That is not true. I is equal to start. So we don't go in this if, and we check here. Candidates at I. What is candidates at I? That's 1. 1 is not greater than target, so we don't break either. And we make another call. So we're passing in our current array plus candidates of I. Current array was 1 plus candidates at I. This is another 1. So our array right now is going to be an array of 1, 1. I plus 1, so that's going to be 1 plus 1, which is 2. And target minus candidates of I. So that is going to be 2. This means we're going to be calling this again with current being 1, 1, start being 2, and target also being 2. So we're back in this function and we have the following parameters. Target is not equal to 0, and now we're looping through. So I is now going to start from 2. And we check, is I greater than start? It's not true. Is candidates of I greater than target? So what is at index 2? That's 2. 2 is not greater than target, so we don't break either, and we make this call over here. So current plus candidates of I, our current array was 1, 1, and candidates of I to that, we get 1, 1, 2. We had I plus 1, I was 2, so that plus 1 is going to be 3. And target minus candidates of I. Candidates of I is 2, target is 2, so now we have 0. That means current is this array, start is 3, and target equals 0. So now once we call combination again, we do go in this if condition, right? Target equals 0, so we're going to append to result our current array over here. And now we can return. We don't need to keep adding things to our combination because we already found our target. Anything else we add is just going to increase that sum, and we're not going to equal target, right? So we're going to return to our caller. We're going back up our recursive call stack. We go back in this function. So when we had current being 1, 1, start was 2, target was 2, and we were at index 2. So we just called this over here, and we're back in this for loop. So now index is going to be 3. So now we make a check, right? If I greater than start, that is true. 3 is greater than start. And candidates at I, that is 2. If this is equal to what we had in the previous index, we continue. We skip. We don't want to do this again because this is going to cause duplicates. So we continue. What this means is we don't go into the other lines over here. We're back in this for loop, and I now equals 4. We check. If I is greater than start, that is true, and candidates of I is equal to candidates of I minus 1. Well, candidates of I is now 3, right? This is index 4, and this is not equal to what we had before. So we don't go in this if condition, and we check here. Candidates of I equals 3, but 3 is greater than target, so we break. There's no point in adding this because we're going to overshoot the sum. And this is a break, not a continue. A continue means we can continue going through our for loop, just not on the index we were on. A break means we break out of this for loop completely. And this is because every other number is going to be greater than equal to the number that we have right now. So if this was going to exceed that target, the other numbers will also be exceeding target. So we break out of this for loop and we return. So we're returning to our caller. That was when we had just 1 over here and index was 1. So we finished going through this call. We're now back in this for loop and I is now going to be 2. So we make checks again, right? I is greater than start. And candidates of I, does this equal candidates of I minus 1? 2 is not equal to 1, so we don't continue. And we check over here, candidates of I is 2. Is this greater than target? It is not, so we call this now. So we're adding 2 current over here, so we get an array of 1, 2. I plus 1, that's going to be 3. And target minus candidates of I. So target was 3. 3 minus candidates of I, which is 2. We're going to get 1. So these are the parameters that we're passing in for our new call. Target isn't 0, so we don't return. We're in this for loop. I is going to start from start onwards. So it's going to be 3 to begin with. And we make a check. I is not greater than start. Is candidates of I greater than target? That is true, right? 3 is greater than 2, so we break and we return. So we're back to our original caller. We move I to be 3. We're back in this for loop and we check I is greater than start. Is candidates of I equal candidates of I minus 1? That is true, right? These 2's are equal, so we continue out of here. We move this back up to 4, and we make a check here. This is greater than start, which was 1, but it's not the same number that we had at the index previously, so we don't go into this if condition, and we check over here. Candidate of I is not greater than target, so we call this. And these are going to be the new parameters that we call combination again with. So in here, target equals 0, so we're going to append this current array to result. So we're adding 1, 3 over here, and we return to our caller, which means we return back over here, and we move I up to 5. So now we make a check over here. I is greater than start, but candidates of I is not equal to candidates of I minus 1, so we don't go into here. Both of these need to be true. And we make a check here. Candidates of I, which is 5, is greater than target, so we break. We exit the for loop completely. We don't even go to this 6 over here, and all we do is return. So we return to our caller. So now we move this up to I being 1. We started off with this 1 over here, right? We're completely done with that. Now we're on index 1. So we're starting from here onwards. We are in this for loop and we check I is greater than start. That is true. And candidates of I is also equal to candidates of I minus 1, which means we want to continue. We're not going to go down this path. This is because if we were to, we'd get the same duplicate combinations. So we're skipping, right? We're back in this for loop. I is now 2. We make the same checks. I is greater than start, but candidates of I is not equal to candidates of I minus 1, and we go into this if condition. Candidates of I, which is 2, is this greater than target? It is not, so we don't break either, and we make more calls. So we're going to be calling this again with the following parameters. We check target isn't equal to 0, and we loop through. So I is now going to start with start onwards. So what is start? That is 3. I starts at index 3, so 0, 1, 2, 3. It's over here. We make a check. I is not greater than start. And we check over here, candidates of I, is this greater than target? It is not, so we don't break either, and we make one more call. So we pass in our current array, which was here, and we add to that candidates of I. What is candidates at index 3? That's this 2 over here. So we have an array of 2, 2, I plus 1 is 4, and target minus candidates of I is going to be 0. So we go back in this function and we call, right, target now is 0, so we're going to append to result this combination here. And we return back to our caller. So we go back into this for loop. I is now going to be 4. We check I is greater than start, and candidates of I is not equal to candidates of I minus 1. Here, candidates of I is greater than target. So we break, we're out of this for loop, and we return. So in our original function now, we're back in this for loop. We just finished going down a path with this call over here. We're going to bump I up by an index, so now it's going to be 3. We make the same checks over here, right? I is greater than start, 3 is greater than 0, but the candidate at index 3 is the same candidate we had at index 2. They're both 2's over here, so we continue, which means we bump I up now to index 4. At this point, I is greater than start, but what we have at index 4 isn't what we had at index 3, so we don't continue, and we check over here. 3 is not greater than target, so we don't break either, and we make another call. So we're going to be calling with the following parameters. Our current array, which is going to be 3, start, which is now 5. Every single time, right, we start at a higher index, and target is now 1. So calling this, target isn't 0, and now we're going to be looping through from 5 onwards. We check, is this greater than start? It isn't, right? These are the same. And if candidates of I is greater than target, this is true. What we have at index 5 is also the number 5, and that is greater than target, so we break and we return. So going back to this function, we bump this up to 5. We go in this for loop and we check. I is greater than start, but what we had at index 5 isn't what we had at index 4. So we don't continue and we check over here. What we have at candidates of I, which is 5, this is greater than target, so we break, right? 5 is greater than the target we wanted to start with, 4. So there's no point in making any combination that has 5 or anything after that either. So once we break out of this for loop, we just return. And all we have to do is return result, which has all unique combinations that sum up to target. Now, talking about space and time complexity. For time, this is going to be 2 to the n if there are n numbers in our candidates, if candidates is size n, because we're checking whether or not to include every single element in our array. We're exploring all combinations, so this is going to be a 2 to the n solution. And for space, we are potentially building up a recursive call stack as big as the number of candidates in our input. So that is going to be O of n for space. So we just went ahead and solved combination sum 2. If you have any questions with this whatsoever, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.